heat energy passes from an object or from one object to the other object is called as the transfer of heat. So either with the same object it can transfer, or either to the different object it can transfer. Now how it happens, it flows with the help of the three processes are there, either with the conduction or with the convection or with the radiation. Then we have started with the conduction part of it, where the transfer of heat will be from a hotter part to the colder part of an object. So we know very well, like if we are, cooking anything or we are just boiling the water, then what happens? The molecules which are present at the bottom, they will be getting the heat faster. And what happens then, from there they will be moving to the upper part of the water, and then the down part again will get hot, then they will move up to the upper part. So like this, from the lower part they will move to the upper part, which means from the down heater part they'll go to the upper colder part of the utensil. So that is what happened in the conduction. It is a transfer of heat from a hotter part to a colder part of an object. Now in this, due to collision of its particle without actual movement of particles from their position. So since it happens between solid and solid molecules, because of this, the collision will be occurring or the vibration will be occurring, and due to this, the movement of the heat energy will be there. So in a solid state, the molecules are closely arranged. So when a solid is heated, the molecules near the source of heat gain thermal energy. So wherever, like we know, if the water is present like this or the solid things are present like this, then this down area will get heat first and they will be passing it to the upper area. Then again the down will get heat, then it will be passing it to the upper area. So this process keep on going until the equilibrium state comes. Then we have studied about the good and the poor conductor of heat. Good conductor, they are materials which will allow heat to pass through them easily, like the aluminum, iron, and copper. Whereas poor conductor, they are the materials which does not allow heat to pass through them easily. Example, plastic, wood. Now, where we all can use this conduction process, actually daily we are using it in our day-to-day life. Utensils which are made up of both good and bad conductors. The handles basically they are made up of poor conductor. So the reason why they are made up of poor conductor, so that we will not get the hot thing on our hand. That is why it is the made up of the poor conductor. Whereas the center part of the utensil, it is made up of the good conductor. It is because then only they will be getting the heat to that part of the utensils. The materials such as wool and cotton are used to make winter clothing, blankets and quilts. So with the help of this, what happened? They will be making the different kind of the materials. Then air is a good insulator, which means it is a poor conductor of heat. Quilt will make us to be the cotton and it becomes fluffy. Now, we will be starting with the second type, which is what is second type of transferring of heat?
Convection.
Correct. So it is the convection. So the second way how we can transfer the energy is the convection. Now in the convection, the liquids and gases participate. So like in the conduction, what was happening? The solid molecules were participating, whereas in the convection, either the liquid or the gases, they can participate. Now in this, what happened? The molecules, they will be, since now they are fluid, they both are what kind of fluids only. So because gases also will be converted anyhow into the liquid, which is fluid. So in this, the molecules themselves carry energy from a hotter region to a colder region. So they do not need any kind of push. They do not need any kind of the extra source for the movement. By themselves, they will start moving. Like for example, now here, this water, this side, it has become maybe hot. It has become hot. The upper layer of the water becomes hot. Now what happened? Automatically, they will be recognizing it and they will start going towards the down where the cold water is present. So that is how they carry themselves. So the molecules themselves, they carry the energy from the hotter region to a colder region. Sometimes what we are doing, we are keeping the water outside in the hot sun. So the upper layer of the water will become hot. So slowly and gradually, that layer will be shifted down into the colder part of the utensil, and then it becomes the same in the nature, or the equilibrium comes. So this process of heat transfer is called as convection. So this process of heat transfer is called as convection. Now, how does it take place? How does convection take place? Any idea how does it take place? Kritvik, Anubhav, Varshit?
Land breeze and sea breeze.
Correct. So what happened in them? Okay, I'll explain you what happened. How does it take place? So land breeze or sea breeze are the just the examples of it, but we should know before that what happens. So now when any liquid, when a liquid or gas is heated. Now, for example, what we are doing, we are heating a liquid or a gas. Now, what it will do? It will start expanding. You might have seen in the kitchen also when the mothers they boil the water, it start expanding. So as soon as we heat the liquid and the gas, it starts expanding, and because of the expansion, and because of the expansion, it becomes lighter. It becomes lighter, and it moves where? It moves upward or downwards?
Downwards.
No, never. The molecules will not move down. The molecules will be moving upwards. So that is how what happens in the sea breeze and the land breeze. The vapors will go up, right? When they become light, the vapors will be going up. Same way in the convection also, as soon as the liquid or the gas are like hot, they will become light and they will start moving upwards. Normally, when you boil the water, the molecules will start expanding and they start going upwards. Now, after this, the next step is the cooler, heavier fluid from the surrounding, the cooler, heavier fluid from the surrounding rushes to take its place. Now, as soon as the lighter, the liquid or the gas which becomes lighter, it starts moving upward. So the space will get empty there. Now, whatever the things, whatever the gases are present around us in the surrounding, they will rush and they will try to occupy that place. And when they occupy that place, then what happens? They will also get heated up in turn. Fine, they will also get heated up in turn. And this process will continue. This process continues and give rise to convection current. Fine. So, like for example, now we have a liquid here. It starts heating. Now, as soon as the upper layer got heat up, the molecules of the upper layer will become lighter and they will start expanding. And when they start expanding, they will become lighter and they start moving up in the atmosphere. Now, this upper space will become empty. There will be like no one to occupy this. So as soon as the molecules, the lighter molecules goes up, some other molecules from the environment, what do? They try to come and occupy this space. And that is how the whole water now get heated up, because The molecules which are present maybe in the surrounding, maybe down, they will start moving up. So that is how the convection takes place. So in this, the liquid or the gas will be heated up, and because of which they will expand, and as a result, they will become lighter and they will move upwards. As soon as they move upwards, the cooler, heavier fluid from the surrounding, they will be rushing to occupy that place, and in result, they will also get heated up. So this process will keep on continue, and they will give rise to the convection current. Now the practical application of convection. So where we can use this convection or transferring of heat. So you might have seen in the kitchen, what you have seen, the exhaust. Have you seen the exhaust in the kitchen?
Yes, ma'am.
Yeah.
So what happened in that case? Why they are fitted so high? So exhaust in the kitchens, they are fitted high. Why is it so?
Ma'am, to take the hot air out.
Correct, correct. So we know now very well with the help of the convection what happened. The hot air from the molecules will go up. Now, if we are keeping that exhaust down somewhere or in the center of the wall, then what happens? The complete heat will not be absorbed by the exhaust. That is the reason they are always the upward, so that whatever the hot air is being released by the molecules can be holded by the exhaust. So, exhaust fans in kitchens are always fitted high, and they will be always close to the ceiling. Close to the ceiling means close to the roof. So they will be close to the ceiling so that they can remove the hot air that rises up. So whatever the hot air comes out through the convection process, they will be able to hold it because the molecules during the convection process, they go up and up. So that is why the exhaust are fitted high in the home. Now, second application where we can use it is in the room heaters. So room heaters now, they are placed on the floors. You might have seen we will not be keeping them high. Why? Why we are not keeping the room heaters high? Why we are keeping them on the floor? Why the exhaust is there? Yeah, tell me.
Because the heat reaches us, it can reach us easily.
Right. So whatever the heat is being released now, they can use it because then only will be getting the hot power or the hot energy. So when the cool air is heated, so we know in our surrounding we will have the cool air, cool air. So when that cool air is heated, it rises up. So as soon as it becomes hot, it will go up and up, and the cold air flows down to the floor. Now, normally, when the cool air is heated, then what happens? It goes up, and the cold air will come down to the floor. Now, when the cold air is present down to the floor, now what we have to do? We have to give the room heater. We have to use a room heater to give it to provide the hot temperature to the room, and this results in effective heating of entire room. So that is why they are placed at on the floor. They are placed so that the cold air which is present on the floor. So here we have what? Here we have the floor. So here what we have? Here we have the heater. Suppose here we have the heater. Now, most of the cold air is present on near to the floor and all. That is the reason the heater is present, so that the radiations of the heater can go out and the cold air can become hot. And that is why, like slowly and gradually, the molecules will come here. Then the molecules of the hot air will go near to the second center part. Then here, then here, then here, then here. So like this, slowly and gradually, the whole room will get heat up. It will get the hot air. And that is the reason they are present where they are present at the floor of the rooms. Now, third one, ventilators. What are ventilators? What are ventilators?
And they are supposed to, remove the heat from the room.
Correct. So they are basically an open window or with a kind of the, you can say, the mesh-like window where small window will be there on the top of our home, like maybe on of our room we can have at the top of it. So ventilators of a room, ventilators basically they are the windows which are present not the down at the top of the room. So ventilators of a room at the top of a window or a door. So why these ventilators are either at the top of a window or of the door? This is because when the air in the room gets heated, so as soon as the air in the room gets heated, what it starts? It starts rises and passes out from the ventilators. Now, if we keep these ventilators down on the floor somewhere or near to the down surface, bottom surface, then what happen? The hot air should go up, right? If it is placed down, then the hot air cannot be released from the room. That is why the ventilators are always present at the top of the door or the window, so that whenever the air gets heated up, it will rise up and it passes out from the ventilators at the top. So that is why the ventilators are always at the top of the window or the door. So these are some of the applications where we are, following it. So in our home also we have ventilators at the top only, so that whenever the air is heated up from there, it then goes out. But during the winter times, it does not happen. So during the winter times, we are just closing all the windows. We want that air should be inside, and that is why we are not using these ventilators during the winter season. So these are some of the practical applications of the convection process. And then two more things are there: sea breeze and the land breeze. In the case of the sea breeze, what happens? It happens during the daytime. Now, during the daytime, the land will become more hot. So since lot of amount of sun radiations are present, so during the daytime what happens, the land will get more heated up, and because of this heating process, the air gets warm and where it starts moving up, it starts moving upwards, right? So as soon as the land becomes hot, the air will get warm and starts moving upward. And why the air gets warm? Because it gets lighter, and that is why it starts moving upward. And as soon as it move upwards, then cool air from sea takes its place. Now, the place of the air will be taken by the place of the cool warm air will be taken up by the cool air. That is what the sea breeze is. So during the daytime, the lands will heat up faster than the sea, so the air above the land will become warmer and rise upwards, and cooler air from the sea, they rushes towards the land, right? They will rush towards the land and they will start taking their place and resulting in a sea breeze during the day. So because of which we will be feeling the sea breeze during the daytime. Whereas in the case of the land breeze, it happens during the night time. It occurs during the night time. Now, doing this, the sea, during the night time, the sea will become more hot. And because of which, the air gets warm and move upwards. From the sea, it will start moving upwards, and from there, the cool air from land will occupy the place of the sea air. So, cool air from land will take its place. So, that is what happened in the case of the land breeze. Since the sea is like more hot, so air will get warm and starts moving upward, and because of which the cool air will start occupying, cool air from the land will start occupying its place in the sea. So at night the land cooled faster, therefore the air above the sea becomes warmer, and then the air above the land, therefore the cooler air from the land will replace the warmer air above the sea. So that happens in the case of the land breeze. So these are the few points or the applications which are for the convection process. So anything you want to ask related to this?
No, ma'am.
Okay, so related, I'll play first video we have seen related to this chapter. Now I'll play the second video.
Heat Part 2. Hello friends, how are all of you? I have had fever for the last few days. I checked my fever on a clinical thermometer and the reading was 100 degrees Celsius, which is approximately 2 degrees higher than the normal reading. Do you remember the normal human body temperature? The normal human body temperature is 37 degrees Celsius or 98.4 degrees Fahrenheit. I'm sure all of you now know about the use of the thermometer. But can we measure the temperature of hot water with a clinical thermometer? I want to know that. Why do hot things become cold and cold things become warm? Let us look for answers to a few such questions through this story. The objectives of this video are: 1. To understand about laboratory thermometer. 2. To understand how heat flows. 3. To understand what are conductors and insulators.
Ravi, drink the milk or it will become cold.
Mother, this milk is still so hot. Can you please make it cold for me? Mother, can we measure the temperature of this milk with a clinical thermometer?
No, Ravi, it can be dangerous. Clinical thermometer is used only to measure body temperature. To measure the temperature of water, milk or the weather, we use the laboratory thermometer.
You kept this hot glass of milk in a bowl of cold water. And look, it has become cold in some time. But look, now this water has become warm. Does it mean that heat flows from hot object to cold object?
Yes, you are right, Ravi. Heat flows from hot object to cold object.
Oh, is that the reason my ice cream melted yesterday?
Yes, children, heat flows from a hot material to a cold material.
Ravi, I brought your science book back. I have a lot of doubts. I will have to ask the teacher a lot of questions tomorrow.
Why? What happened? Why did you not understand?
I have doubts in the chapter on heat.
Ravi, can you please stir the vegetable on the gas with the spoon?
Oh, this spoon is so hot.
So in this case also what happened, since the conduction process was happening, the utensil was hot, and we know very well the transferring of heat takes place, and the spoon is like the made up of the aluminum, maybe the iron, maybe the steel, and that is the reason it also got hot.
There is a wooden spoon. Use that.
And wooden spoon, they are poor conductor of heat, that is why they will not get hot.
Oh, this wooden spoon did not get hot. But that steel spoon had become so hot.
Yes, there is mention on the same in our science book too. But what could be the reason for this?
Ramesh, let us do an experiment. Let us take different objects made up of different materials. Then let us dip them in hot water one by one. Let us then observe what happens to each object.
Children, I shall warm the water and give it to you.
Look, Ramesh, I have this wooden spoon, steel spoon, this pair of scissors, this plastic scale, and this ceramic spoon. Come, let us dip all of them in this hot water.
Look, Ravi, this steel spoon has become so hot, and this wooden spoon, plastic spoon, and ceramic spoon haven't become hot.
This pair of scissors made of iron has become so hot. Yes, Ramesh, I have also noticed that when we play on the slides in the park, the slide made of iron becomes so hot.
So, it means that some materials like wood, plastic, etc. do not let heat pass through it.
And materials like steel, iron allow heat to pass through them.
Good observation, children. The materials which let heat pass through them are good conductors of heat and are known as conductors. The objects which do not allow transfer of heat are poor conductors of heat and are known as insulators.
Oh, that is the reason a few utensils have plastic handles. Because if the utensil contains something hot, the heat does not transfer to the handle and we do not burn our fingers.
Yes, you are right. The sun also gives so much of heat, and because of that, the air and water in rivers and sea becomes hot. So are air and water conductors or insulators?
Friends, we learned that heat is transferred from a hot to a cold object. The materials which let heat pass through them are known as conductors, and the materials which do not allow heat to pass through them are known as insulators. Ravi asked a question. What could be the answer to that? Are air and water conductors or insulators? We shall look for the answer to this in the next video. We shall
Now we'll go to the third part now, the last part of this. So this is the last part of it. We are telling about the land breeze, sea breeze, and the other important points.
heat. part 3? The objectives of this video are 1. To understand about convection. 2. To understand about natural convection in coastal regions. 3. To understand why do we wear clothes according to the weather. Hello friends, how are all of you? I had been to Goa for a few days. Goa is a beautiful beach destination in Maharashtra. How is it that a beach always has a pleasant atmosphere? Have you ever thought that why do we wear light colors in summers and dark colors in winter? Come, let us find the answers to such questions with the characters of this story, Mala and Raja.
Mother, I want hot water to take a bath. Can you boil some water for me?
Yes, Raja. Wait for a while till the water heats up.
Mother, the water close to the flame heats up faster, right?
Yes, Raja.
Then all of the water heats up together.
Like you said, that the water near the flame heats up first. Then it rises up. Then the cold water around it takes its place. Then similarly, the water heats up and rises. This continues till the whole water in the vessel heats up. This is known as convection.
Is convection also a method of transfer of energy of heat like conduction?
Yes, you are right, Raja. Convection takes place in liquids and gases.
The air also heats up because of the sun's heat. So, does it also rise like water?
Shall we do an experiment? We will need these materials: a broad cylindrical glass tube, one candle, one incense stick, one round cardboard with 2 holes, tape, matchbox. Come, let us light the candle and place this broad glass tube over it. Now cover the glass tube with the cardboard and secure it with the tape. Remember to place the cardboard in such a way that one hole is right on top of the flame of the candle. Now light the incense and place it over the other hole. Now let us wait and watch what happens.
Look, the smoke from the incense stick is coming out from hole above the candle.
Yes, but how did the smoke from the incense go inside the glass tube?
Think.
The hot air around the candle is coming out, and the cold air from around the incense stick is going inside.
And then the air which went inside is becoming hot and rising from the other hole.
Good job, children.
This means that hot air rises and the cold air takes its place.
So always it happens like whenever the hot air comes up, the cold air will be taking its place. So you can see like how the movement is taking place.
Mala, do you remember that in the science exhibition in school, a child had made a model in which he had explained something about the similar flow of air around the seaside?
Yes, I remember, but not clearly. Come, let us read in our science book. Look, it is written here that during the day the land heats up faster than the water and the air above it rises to occupy.
So in the daytime, the land will become hot, the air from the land will goes up.
that space, cold air from the sea
And then when that space will become empty, the sea, from the sea, the air, the cold air will move into the land. So that is how the movement takes place.
comes in and takes its place. This is known as sea breeze. During the night, the opposite happens. Water in the sea cools down slowly than land, and therefore cold air from the land blows towards the sea, and warm air from the sea comes and takes its place. This is known as sea breeze.
This explanation is exactly like the experiment we just did. Like the cold air from near the incense went in and the hot air rose up from above the candle. Likewise, the currents around the seaside are examples of natural convection. The sun also gives us heat, but there is no medium between the sun and the earth. So then, how does the heat from the sun reach us?
So that is because of the radiation.
Yes, a medium is required for transfer of heat in conduction and convection. So how does transfer of heat take place without a medium from the sun? Come, let us look in the book. Look, it is written here that the heat from the sun reaches earth through radiation.
Radiation. Show me the book. It is also written here that there is no medium needed for radiation. That means transfer of heat takes place by three means: conduction, convection, and radiation.
Raja, wear something warm. It is getting cold now.
Mother, warm clothes gives us warmth. In summers, we wear light clothes with light colors.
Yes, you are right. We wear light colored clothes in summers because light colors reflect the heat and hence we feel less warm. And in winters, we wear dark colors because dark colors absorb heat and hence we feel warm.
So since light color reflect the heat and the dark color they will absorb the heat, that is the reason that always in the summers we wear the light colors cloth, and in the winter we wear the dark color clothes.
Oh, so let me wear my red sweater.
Now the water mother heated for you to take a bath has cooled down. Let us do our homework or else the teacher will scold us tomorrow.
So, friends, you understood about convection.
So that's about the chapter heat. A small topic is remaining, which is the radiation. That we'll be doing it tomorrow. Any doubt, like if you have Varshit, Kritvik, Anubhav, Yashwant?
No, ma'am. No, ma'am.
Anubhav, turn on your video. And tomorrow, along with the topic radiation, we will be doing the assertion reason also. Assertion reason of the chapter heat. All right. So where you need to identify the correct answer. I think now you are aware what are the assertion reason questions, right? So those kind of question comes usually in your entrance exam, maybe the NSO, maybe the Olympiad exams, maybe any other exams, bank exams, other exams. So it comes there. So we will be doing those questions because radiation I will be completing within 10 minutes. So remaining 15 minutes, we will be doing the assertion and reason questions tomorrow. And I think nutrition in animals also we have not done the assertion reason, I guess. Or we have done.
Ma'am, I think we haven't done for acid bases and so on.
Okay,
Ma'am, we have
then
done
we
for the plants and nutritions, ma'am.
okay. Then we'll do it for tomorrow. We'll do it for the heat, and we will do it for the acid, bases, and salts. Okay. So okay, now start doing the MCQs. I have uploaded that under the homework with the name heat MCQ 06122023.
Ma'am, my video is turning off and saying that your internet connection is unstable.
Okay.
Ma'am, with the name of 4 transfer of heat.
Yeah.
Ma'am?
Yes, correct, right. Transfer of heat with the name.